Robo Nation, for coming on board here. Thank you for tuning in. Thank you for everyone that's going to watch this after the fact. We are live. We had some technical difficulties the first time around. I'm trying to connect over to Adam in Ohio, but we figured it all out. So we're about an hour and 15 minutes late, but hopefully you guys tune in. You're still able to get some of this information. So as you know, we've been doing these Robo Lives every week. This is number 14, which is really exciting. So we're going to keep this up, stay consistent with it. We film everything now from customers to companies that make filament to all sorts of different people. So we're going to try and bring industry experts in a couple of different areas and, interview them and talk about some of the things that they're doing to help inspire you or help you create more with your 3D printer. So without further ado, I'm going to introduce our guest today. His name's Adam Davis. He's an engineer. He's a front-end innovation at Owens Corning. So we're going to bring him in. We're going to talk to him about some of this high-strength material that I've been showing on the Instagram channel and some of our social media pages. So let's go ahead and bring him in. I'm going to cut the split screen here. If you guys have any comments, go ahead and type them below, and I can bring them up on the screen and ask Adam here. Adam, how you doing, man?
Good. How you doing, Braden?
Good, good. Thank you for coming on board. Sorry for all the problems with the technical difficulties we had, but I'm glad we're live now. I'm glad we're making this happen. So it's good to have you on board. So thank you for taking some time.
Thank you.
Yeah, so Steven said, can't wait to learn more about this. Cool. Yeah, we're excited to learn about it. Adam, so the first thing I always ask people that come on to our channel is tell me a little bit about yourself. Tell me who Adam Davis is.
Yeah. So my name is Adam Davis. I'm one of the additive engineers for Owens Corning. I work at the Science and Technology Center, Greenville, Ohio. My whole job here is really all about additive. My shop, as you can see behind me, this is my office/lab, right? We have about 8 to 9 printers. We have multiple types of additive technologies here. And again, we're like a one-stop shop. So my lab, we collaborate, innovate, we develop processes, new tools, new functional parts. We have 3D scanning. We have anything related to design. We even have reality, which is really cool to be able to do 3D modeling.
That's pretty awesome. Yeah, I see you have a little robot moving back there.
Yeah. So we call that the Skinner bot, right? That's my nighttime.
Nice.
And it keeps anybody out of my lab.
Oh, there you go.
So check the status of my prints when I'm not here. So it's pretty cool.
Oh, nice. You can control it remotely from home.
Exactly. Yep.
That's pretty sweet. Actually, that's a pretty nice little tool there. I've seen those. Obviously, we go to like the CES shows all the time, and I see robots like that, but I actually did not think about using it specifically for that reason.
Yes. So this is actually a Beam Pro robot. So.
Okay. Nice. Cool. So you have tons of different machines. You've used everything from industrial to desktop machines. Yep. And I'm excited because we just started working with you guys with some of this new material. In fact, I did an Instagram story where I was testing the strength of some of the materials. We've been doing quite a few posts, and we created an expert bundle because I know one of the things that the material requires is it can be corrosive on the nozzles, correct? So putting a nozzle that has either hardened steel or a ruby nozzle or something onto it is something that you want to do, correct?
Yeah, correct. Your standard brass nozzle, bronze nozzle is going to last for about 2 to 3 kilograms.
Yeah.
Ideal is a tool steel nozzle or a ruby tip nozzle.
Cool. And how did Owens Corning, you guys have been around for how long? 80 years almost?
A long time.
Yeah, I mean, I think I read since how long, do you know?
Owens Corning has been around for 60 years.
60 years, okay. I knew it was a long time because I remember watching it and I was like, oh, this is just incredible. So how did you guys get into developing a 3D printed material?
So when you think about it, there's a gap currently in industrial materials for sure. Your hobbyist users, right? When I was first in 3D printing about 5 years ago, you could count the amount of materials on one hand, right? And you really had options with your simple PLA and ABS. And over the past 5 years, you can just see how the innovation, the amount of materials. I mean, today it's unbelievable who's all getting into the material industry. However, with that being said, there's still that gap between the hobbyist users and the industrial users, right? And what we focus on is really that industrial user that wants to make a functional part, whether it's a replacement part or a line trial part. And so really that gap is between the unfilled resins and injection molded parts.
Yeah,
so,
correct.
And obviously with Owens Corning in the glass filled area, we're adding our fibers to the material to add strength.
Yeah, we've been, I printed with, someone said, Adam, if you can go a little bit, I think he said speak up, but if you can get a little bit closer to the computer. Right. I think it's not picking up on their end that well. But yeah, I printed with a ton of different materials out there. Obviously, we do this all day, every day. So I'm printing with even the stainless steel infused materials, the bronze infused, all the metals. And I remember the moment I felt the Owens Corning material for the first time was I think it was at TCT in Birmingham. And I was holding it and I just was like, whoa, this just feels way different than anything I had felt before. So I knew, like, from a strength standpoint, just from the feeling of it, that it had properties that, were obviously far superior than a lot of the other materials that were out there, if all of them. So it was pretty cool to kind of experience that. And now that I'm actually printing with it and testing some of it, I don't even have the testing equipment. So I'm doing like funny tests. Like I'm hanging from, I printed a tensile strength test and I'm hanging from the wall. I was putting all my weight on it, trying to break it. And obviously it withheld, thank God, or I would have fell on the ground. But what kind of testing, what extent have you guys gone with strength testing this?
So when it comes to strength testing, when you compare our material to standard ABS, you're looking upwards of 250% of the mechanical modulus. We follow all the ISO standards that you would with a standard 3D printed specimen when it comes out and that sort of thing.
Cool. You personally, are you using the material quite a bit to make high strength parts for certain applications?
Yes, we are. So the main thing that I focus on is putting functional parts in our manufacturing plants.
Okay.
We have manufacturing plants all over the world, and I focus on the U.S. based manufacturing plants. I work on replacement parts, definitely line trial prototypes.
Mm-hmm.
They have to be able to withstand the environment, and our manufacturing is critical. We also make a lot of truly functional parts. If you think about it, a lot of the maintenance team and engineers, they'll buy parts on, let's say, McMaster car or Granger.
Yeah.
They'll buy the parts and they'll modify them to how they want to use them. And now, ability to design exactly how we want to and use them in that given application.
Yeah, I always, speaking with like an organization such as Owens Corning, it sounds like this material was spawned from a need to have it internally first. And then you realized, okay, this is a material that the industry can benefit from as a whole. And so let's release this and sell it on an actual spool that we can manufacture a large quantity. Is that kind of how it worked from your knowledge?
So with Owens Corning, right, we have a lot of glass. We have glass. And where are we going to put that glass? The 3D printing industry is just booming right now, right?
Yep.
So what you don't see a lot of are materials out there that have this side to add all your mechanical strength and properties. We wanted to add it as a commercially available product, but we also utilize it in our manufacturing plants to save costs. Yeah,
that's cool. Yeah, it's I've tested like putting water on it and all that. It's very water resistant. It's got a beautiful finish, so most people would relate it to like the carbon fiber type finish. It's got that really nice matte look to it. You can't even see the layers. And it prints pretty similarly to, like, obviously different temperatures, but it prints pretty well on just a standard platform. So our machines come with like a Build-Tack surface, and it prints right on the Build-Tack surface. If you put a little bit of adhesion, like a glue stick or something on it, it's a little bit better. But for the most part, it prints pretty clean, which is nice too. So that was definitely a benefit of using it. And like I said, I still want to test it a lot more. Do you have any recommendations for me when I'm testing it? Any specific way? I haven't tried printing like vertically and testing strength from a vertical standpoint. I printed most things just flat. and then tested it from there. Any recommendations on your end?
So with the polyamide 6,
Yeah.
typically every slicer program, right,
Yep.
have a nylon preset setting.
Yep.
That is set to start with a nylon for the polyamide 6, right? Yep. A really cool test you can do is print a vertical column.
Okay.
Let's say you were to print a standard ABS part, let's say like a dog bone, right? And you were to print it vertically.
Yep.
Break it, your weakest layer is through your Z direction.
Yep.
And break like a dog bone vertically, it's just going to shear between layers. What you'll see, material is when you break it vertically, it's going to shear amongst multiple layers because those glass fibers inside act as a mechanical link between the upper and lower layers.
Ah, interesting.
That's one thing to pay attention to when
okay.
Because really we want to reduce the way that, a big consideration is always orientation of your print to get maximum strength. And by adding fibers to the material, we reduce the thought concept of using orientation into the mechanical properties.
Yeah. You know what's interesting is that actually makes a lot of sense because we took a PLA plastic material and it was like these little strength tests and we ran them both over by a car. And what I noticed was the PLA just kind of crushed when your material crushed it. When it broke like in these like long angles,
right?
And more in like 2 or 3 pieces, whereas the PLA just kind of just disseminated.
Yeah.
So it was interesting to kind of watch that, and it has really good compression to it. I noticed as well. So I know that's the one reason why people like to use ABS too. Not only is the strength, but the compression capabilities that it has. And it seems like your material has compression capabilities that are superior to an ABS as well, which is cool.
Correct. Yep.
So I know you have some pieces. Can you talk about some of the pieces you have with you, or one of the pieces you have? I don't know how many you actually have, but.
So I do have a couple of pieces in front of me. The one that I'll show you. I kind of call this kind of like a torture test, right?
Okay. There we go. Nice. Oh, yeah, that looks great.
So this was a 1-part print. No supports, no raft, no special.
Yeah.
No, that's the great thing about 3D printing is sometimes the most complex shapes are the easiest to print. But what I'm trying to show you with this is the fact that our material has great bridging properties.
Yeah.
So, you typically think about a 45-degree angle, and I always push the limits to between 40 and 44. Yep. And at the top of a curved surface, we don't want any, any layers that are unattached. And so I print a lot of these to show people that because you can't do that with your standard ABS nylon materials. So that is one good.
Yeah, I was printing that same test. I wish I had it, but I ran it over with the car. I was printing these like strength tests, and they have these big gaps that you have to basically bridge over. I didn't want to use support. I wanted to try it just without the support. And I noticed that PLA had like a lot more droopage. Your material just went right across the top. I had barely any droopage at all, and they were pretty big gaps. So the bridging capability on it was definitely like far superior as well. So it was cool. I like printing with new stuff. I like testing new things just because, once again, I mean, for me, I can use the printers in different ways to showcase it to the audience, but I know our audience that uses it in all forms of industrial applications and personal applications can then take it and go to the next level. So it's always advantageous to see things like this happening.
So one thing I wanted to say real quick when printing tricks.
Yeah.
If you do have to print supports for any reason, make sure your gap between the support and the part is big enough, because if it's too close, it'll be almost impossible to remove that support. Other thing you can do if you have a dual-headed extruder is use like a HIPS material, and the HIPS material will make a great bond between the supports and the part itself, and easy to remove.
I was going to say I did try to print one of those wrenches, the adjustable wrenches, and I don't think the gap was big enough. Right. And I had a hard time getting the support out there, so that's a good tip. for people that are printing with this. But I can tell you in terms of the strength of it, a lot of it, I mean, even this is the piece that obviously like the tensile strength test print piece that I was like literally hanging on this thing using all my weight and trying to rip it apart. I could not get this thing to rip apart, nor can I probably even break this piece. I mean, it's so strong. And I've been testing, like I made this hammer and I've been hitting a bunch of stuff, throwing this on the ground. You can see like dent marks on it. I can't get this thing to break. We ran this over by like a car. I tried to find a tractor because I wanted a tractor to run this over. So that's gonna be my next thing. That's gonna be my Instagram channel. But yeah, it's like I said, it's just one of those materials. And if you look, anyone that's looking at the post right now, if you look below, I should have mentioned this when I did the intro. You probably saw it. Is there a material data sheet on there? So for all the engineers that are out there that want to look into the mechanical properties of it, the thermal properties of it, it's all down below in that material safety sheet. We talked about it on our forums as well, so you can get all that information on it, which is really cool. And you guys have probably done the most extensive testing I've seen of any material that's like publicized. So it's good to kind of see that.
We have a full team in Chambéry, France that is dedicated to the development and testing of the X-Strand product line. So they've done a great job.
Cool. Yeah, I love it. I like the name of it. I like the strength of it. So I have more to test that I want to do. But it's definitely exciting. Is there anything else we can expect from Owens Corning coming soon that we can talk about? I know it's always a tough question because there's certain things you can and can't talk about. But
so there is some ongoing right now, right? That
yeah.
will be released this year in 2018 to
okay.
that X-Strand product line. And they're going to be some pretty unique materials that are going to add more to strength. And you'll be able to print parts that you normally wouldn't think you would be able to print on a 3D printer. So
cool.
Stay tuned for sure because there's some pretty exciting materials.
Yeah, this is good. It's taking 3D printing to the next level, which we need, especially desktop, because we want more desktop applications, especially in large companies on the desks of engineers. So being able to kind of take their desktop printers and start making really usable functional pieces in industrial applications is going to be huge. So, obviously I appreciate you guys being involved in it, releasing more materials. You guys have 2 materials right now, right? The one we're selling is the polyamide 6 right here, but you guys have another material as well. I think the reason why we didn't sell it was our stock platforms. It didn't work very well with it. This one works great. So what was the other material that you have? What's the name of it?
The other material is a polypropylene that's also glass filled.
Okay. So yeah, this one, you can pick this one up at our store. We have, for anyone that's watching this, we have this and we have the Olsen Ruby nozzle, which is a corrosion resistant nozzle. We have like an expert bundle we're doing with Owens Corning and material on that. So you can pick that up on the website. If anyone has any questions, on a side note, if you have any questions that you want to type after the fact when you're watching this, because we're not on the live, just go ahead and type them in the box below and I'll reach out to Adam and I'll get some answers and I'll respond. And we'll keep this conversation going. And hopefully, Adam, we could bring you back on when you come out with a new material and we can talk about that specific thing. Is there any other things you want to talk about and any material, any prints that you have? Or some of the applications that you're like really excited about that people are using it for.
So there is actually, you can get online and there's some videos with a company called Sea Air. Okay. Yeah,
I saw those.
You check that out? So
yeah, it's really cool.
They're making hydrofoils with our X-Strand product. So yeah, you can make a boat fly with 3D printed hydrofoils. Is that
actually live? Can I post that on the comment section after this?
Yes, you can.
Is that video? Okay, so I'll post a video for everyone if they want to watch it below. It's a cool. You got to watch it. So really unique use case for it. That's what I love about this industry is these use cases come out of nowhere. Sometimes we never even thought they would be used for those certain, specific things, and then they come out of the woodworks, and there's just these amazing stories. So I'll post that for you. Any shout outs you want to give before we get out of here, Adam?
Jay, Chris Anderson.
Yeah. Wait, the Chris Anderson.
The Chris Anderson. Yep.
Oh, I didn't even know you were working with Chris Anderson. I love that guy. He backed us on our first Kickstarter, which was pretty amazing. So I met him at a show, and I've been talking to him ever since. So he's a good guy. So yeah, we'll stay in touch with you. Thanks to Jay for setting this up, and thank you for coming on, Adam, and taking some time. Thank you for dealing with the technical difficulties. Yeah, I know that isn't easy, but I appreciate your information and some of the tips and tricks for printing with the Owens Corning materials.
Thank you, Braden.
Thanks, bud. Talk to you soon.
Alrighty.
Bye.